Hello everyone, welcome back. My name is Mr. Dean Cobalt and I will be going over today random error and systematic error. In my last video I talked about accuracy and precision and I used a few graphs. I'm going to be using those graphs again to kind of go deeper into random error and systematic error. So again, for those of you who didn't see my other video, you can see that these graphs are representing precision and accuracy. And just to remind ourselves what precision and accuracy is how close your value is to the actual value. Or in other words, how close your shot is to the bullseye. And precision has to do with how close your individual measurements are to each other, and that's represented by how close the red dots or how close your individual shots are to each other. Do you have a nice tight cluster, or are they spread out? So you either have imprecision or accuracy in your shooting, or in your measurements, and so I'm going to kind of tie this into random and systematic error. So random error is error that has the same probability of being too high or too low. So what that means is in your instrument, there are going to be in any measurement inherent errors that you just can't get away from. You can do your best to avoid them or limit the number of errors or in your measurements, but there's always going to be some sort of error, and that's the random error that either makes your value go too high or too low, right? So for example, if you got a really sensitive balance, the wind or air current, not even wind, air currents, convection currents, things like that can affect the balance. And so one measurement, if you're weighing the mass of something, one measurement might be a little higher than the next one, right? So you might weigh it again, and then it's like a little bit lower, and then you weigh it again, and it'll be higher. So that fluctuation in your measurements, being too high and too low, that's what we call the random error. So it's an equal probability that it's going to be high or low at any given moment when you're measuring. Okay, so that's a random error. And random errors, those can be averaged out, right? If you take enough data points, or if you do enough trials of your experiment. This is why it's very, very important to do many trials of an experiment, so that way you get enough data points that when you average them, you can average out the random error. So if you only do one trial, you can't average, right? So who's to say that one measurement had a random error that made it too high or too low? You don't know, right? So, and even if you had two trials, you average those together, both of them could be too high or too low. So that's why we want to take a lot of data points, so that when we average them, we're getting rid of that random error, that equal probability of fluctuating up and down. And you can see that here. Sometimes if you don't take enough data points, it's not going to average out. So for example, in this bullseye, you can see that they're spread out and it's not precise. But you can see that they go over to the right. So you can see that on this side of the bullseye, not very many shots, but over here we tend to get shots. So even if you average this out, you wouldn't get close to the bullseye. You couldn't get rid of that random error. But if you were to shoot at the bullseye more often, like take more shots, maybe some of the shots might end up over here, and then therefore kind of canceling out what was over here. So when you take the average, you get close. You get a number, or you get an average that's close to the bullseye. And so that's what we kind of have going on here. So, or at least you got here, here, and here. So you can see that there's large fluctuation in the data. So this is imprecise individual data points. This is imprecision. But then if you take the average, you kind of get rid of some of that random error, and you can see that the red dotted line, the average is 10.13, which is, you know, closer to the actual value of 10. Not quite there, so it's a little inaccurate still, but if we took more data points and averaged that, then maybe we could get closer. Okay, so same thing here, data points. Let me get this down so you can see here. So in this one here, you got the data points are lots of fluctuation, so there's imprecision, but if you take the average, it's right on the actual value. So the averaging will get rid of the random error. Now, systematic error is error that tends to be too high, too low, consistently. So every time you use the measurement, it keeps giving you a higher number than what the expected value is, right? Or a lower number that's expected. So that would indicate that you have something wrong with your instrument. You got to calibrate the instrument. So it's the same thing here. If you're shooting at your target and your gun or your bow and arrow, whatever you're shooting, consistently goes up to the right, up and to the right, and you create a little a little cluster here, that would indicate that you are shooting. Your shooting is pretty precise, right? So that's good, but you are consistently shooting in this area, but you're aiming here. So that would indicate, excuse me, let me bring this down. So if you're aiming here and you're consistently getting here, then that indicates that there's some systematic error in your instrument that you're using, your gun or your bow and arrow. Or so you guys check the sight on your gun or your bow and arrow. All right, so so that would be a case where you have a systematic error, and you can't average this out. So even if I took this and averaged those, it still would wind up here. So my average would still be in this area. So I can't average out the systematic error. It's just something inherent in the device. There's something wrong with the device that I gotta fix. Maybe I gotta calibrate the instrument. Usually that's the case. Or maybe it's just a defective instrument that you're using. Okay, so you can see in the data here where you've got you would have a systematic error here because you are very precise, so it's repeatability in your data, but when you average them, it's still pretty far from the actual value, and they're consistently low. So that seems to indicate that your instrument is reading low, and so you gotta get it fixed or calibrated. Okay. That's pretty much all I wanted to talk about with regard to random error and systematic error. Systematic error is usually an error where you tend to give too high values or values that are too low, and that's something you can't average out. It's something you got to fix in the machine itself or the tool. Also, the random error is error where things have an equal probability of being too high or too low, and there, if you take enough data points or if you do enough trials, you can average out that error and get more accurate data from the average. This is why when we collect lots of data, we average that and we report the individual data points not so important, but the average of those data points is what we're looking at, and usually what we report in our lab reports, okay, or papers or articles that you're publishing. Okay, I think that's it for this video. Thank you for joining me. If you like this video, if you like the channel, please subscribe, hit the bell, make a comment, share the video with others. Okay, I'll see you guys next time. Thank you.